guide you here. So sketch the graph of this function. It has to, this one has 3 zeros. So it has a 0 at x equals 1, x equals -1, and x equals 2. Because you said each of these equal to 0.
Mhm.
So that's one way to do it. Although these graphs aren't very good, but you can probably see that this one kind of has the best one, because although I guess it could be this one. These sure aren't very good to do this with. Yeah, normally they give you a little better graph to be able to make this decision. Do you know if C is the correct answer? Do you have those with you?
I think it is C.
Okay. Now, another thing we know is that when you expand this, you get x cubed plus a bunch of other stuff.
Mhm.
And whenever the power is odd, it has to start low and end high. So that immediately gets rid of that one.
Yeah.
Okay, but it doesn't exclude these other ones. And it's just hard to see. This one's only got like one positive x-intercept, and we know that it's got 2 here. So so not, I mean there's a little better picture would help.
Yeah.
All right, so we have express the equation in logarithmic form. So this is one of those, like, you either know it, you see it, and you can get the answer, or you maybe have to work them backwards. Do any of these stand out to you as being correct? Can you, like,
I think it's A.
okay, so A, if we undo it, if we write 3 to the log base 3 of 10 equals 3 to the 1000.
Mhm.
These cancel and you get 10 equals 3 to the 1000.
Mhm.
So it's different. So it's not A. A is out here. So let's look at B.
Okay.
Log base 3 of 1000 equals 10. So if you use a 3 on both sides here, this cancels. You get 1000 equals 3 to the 10. We're not looking for that either. We're close, right?
Mhm.
So C, okay, if you do 10 on both sides, you get 10 to the log base 10 of 1000 equals 10 cubed, and we finally have it, because 1000 does equal 10 cubed.
Mhm.
So like, I guess I don't really have a good strategy other than, like, you have to know how to move back and forth between them.
Mhm. All right.
So whatever it is that allows you to do that, you want to be on top of. 3 is something you and I have not covered yet. Maybe you've been covering it in the last few weeks.
Yeah, a little bit.
Okay. All right, so lots of things here to do. 3-0. Okay. So there's a really good resource. Let me find it here on conic sections.
Okay.
Okay, here it is. And here's the one. I'm going to snip in the ones for ellipses, because that's what these are. Okay, so what they're giving you here is the focus. They're giving you one of the foci. They're saying that the focus is at 3,0.
Mhm.
So the foci, and the other one is at, we'll assume it's minus 3,0. So when it's in this format, this is where there's like a lot that goes into this. The y values are the same, so we know it's one of these, because I'm looking at this right here, and the k value is staying the same, which is 0. Okay. So and this in this format here, A is always greater than B. So that means the number under X has to be greater than the number in front of under Y. So that gets rid of that one. It gets rid of that one. So to find this value of K, I'm sorry, this value of C, we have to use this equation down here.
Mhm.
So it's a squared equals b squared plus c squared. It's not Pythagorean theorem. So it's like, okay, well, does we think that c is 3.
Mhm.
So that's 3 squared, and then b squared is so this is 6 squared. This is square root of 27. I don't know. There's a lot going on out here. So is this true? And it is. So it ends up being this one, but I don't feel like that's clear. I would graph a few of these, like to try to figure out like how to understand like using like Desmos, like which way does this type of one go and which way does the other one go. That might help to do these.
Okay.
And another thing that's interesting here is this one is kind of just all over the place. Like now we're doing a range problem. So you might want to try to, when you're doing this on your own, to try to like look at kind of grouped questions if you can. Are you allowed to use a calculator on this?
I'm not sure.
Okay. So the range is the y values. So if you have a graph of this, you can maybe figure out what's going on.
Mhm.
So e to the x looks like this. When you have a negative in front, it looks like this, e minus e to the x. But then the 1 is really added 1 to it, so it goes up 1. So this is 1 minus e to the x. So what is the biggest y value that this can take on? And you see that it's 1.
Mhm.
So 1 is not included because it just approaches the value. It doesn't actually ever equal the value.
Okay.
So 5 is actually our first problem. Sorry, I should circle that. 5 is our first problem where it kind of is something similar to what you've done already.
Mhm.
To undo a logarithm, let me set this in here. To undo a logarithm, you have to use the base. So like it's 4 to the log base 4 of x equals 4 to the 3. The reason you use 4 is because there's a 4 there, the log base 4.
Mhm.
So on the left, it cancels, but on the right, it's 4 cubed. 4 cubed is 4 times 4 times 4, which is 64.
Mhm.
All right, so would you like us to do this review in a different way, or is this working for you?
Oh, this is good.
Okay. All right, number 6, it says to use the laws of logarithms. Okay. Another way to say number 6 is to rewrite the expression. So there's a bunch of things kind of in play here. We're looking at this up here. The first is that there's really a 1 here above the 13, power of 1.
Mhm.
So the first thing is that you can write log base 7 13 to the 1 over 8 power. And if that isn't clear here, there's really a 1 here and a 2 here. That's why this is x to the 1/2 power.
Mhm.
Okay, so sometimes you need like a reference to remember these over here. So then the last one, the next property is that you can actually bring the exponents out in front. That's log base b x to the n becomes n times log base b of x. So in your problem, you can actually bring that 1/8 out in front. So that looks like letter C again.
Mhm.
All right, number 7 here. The graph of a polynomial function is given. It's just this part. I'm not sure why it's shaded in. But the extrema here, that refers to mins or maxes.
Mhm.
And mins kind of look like that and maxes look like that. So we got one there and we got one there.
Yeah.
So you got to just find the coordinates of these.
So -1, 0, and 2, 3.
Yes. We like those questions. Those are good ones. Hopefully you'll get a bunch like that. Another thing I guess I'm not seeing is like sometimes in the past they would give you like multiples of the same style of question, so you knew that that was on there. You know, I'm not quite seeing that yet here. Okay, so domain and range of the function. This is a quadratic, and quadratics either open up or down. Okay, this one actually opens down because there's a negative in front. Okay, so it looks something like this. So to find the range, we need to find the vertex.
Mhm.
The vertex you can get from formulas. The vertex is x equals minus b over 2a.
Mhm.
A is -4, B is -8, and C is 7. So that's minus and -8 over 2 times -4, 8 over -8, which is -1. But that's only the x coordinate. You really need the y coordinate of the vertex. So to get the y coordinate, you take that value of -1, and you put it back in. So it's -4 times -1 squared minus 8 times -1 plus 7. So when you simplify this, you get -4 plus 8 plus 7. And that equals 11. So that's a pretty good indicator of where it is. So that when a quadratic, when it opens up, the range is the y coordinate of the vertex
Mhm.
to infinity. But when it opens down, the range is minus infinity to that y value. So since yours opens down, it's the second one here.
Mhm.
The domain is always minus infinity to infinity, so that's why it's this one. Is it okay if we move on to 9? Is this clear enough?
Yes.
Okay. Find the slant asymptote of the function y equals x squared over x minus 1. So they're telling you they want this, but what that really means is you need to divide.
Mhm.
And there's 2 ways you can divide. You can do long division, or you can use synthetic division.
Mhm.
All right, so do you know what you're dividing by? Did you say they're dividing by x minus 1? So the first way is x minus 1 outside the house, x squared plus 0x plus 0 inside the house. That's way 1.
Mhm.
The other way is to put a 1 out here, and then the coefficients 1, 0, and 0, and do synthetic division. Which one do you think you would do on an exam?
Synthetic division.
Okay, so you just got to remember to put those extra terms in there. So you bring the 1 down. 1 times 1 is 1. That goes here. Add 1. 1 times 1 is 1. Bring the 1 down. Okay, this is your remainder. This is not important in this problem.
Mhm.
But it was x squared, x, and number. So it goes from x squared to now x plus 1. It's 1x plus 1.
Yeah.
Okay. Any questions on that?
No, that one makes sense.
All right. These are good questions. They do seem very different than the ones you and I have been working on.
Yeah.
Okay, give the domain of the following function. So whenever you have an even root, even root, the inside has to be greater than or equal to 0.
Mhm.
You can only take the even root of a positive number or 0. So in other words, we're saying x squared minus 6x greater than or equal to 0.
Mhm.
So to do this correctly, you want to factor out an x minus 6 greater than or equal to 0. And you make a little number line. That's 0 and that's 6. And you try to figure out well, what happens in each of these windows?
Mhm.
Well, when x is over here, let's say it's 10. 10 times 10 minus 6 is a positive number. Because it's like, I don't know, it's like 40. But in here, let's say it's 3. It's 3 times 3 minus 3, which is negative 3. Positive times a negative is a negative. And then over here, let's say it's like negative 5. Negative 5 times negative 5 minus 6, negative 11 inside here. Negative times negative makes a positive. I know we haven't done this, but did you understand? Did you follow what I said there? Is that
Yeah.
okay? So now we want to know again where it's greater than 0. So that's over here, and it's over here. So it's from minus infinity to 0. And it includes 0 because it's greater than or equal to. And then the other one is from 6 to infinity. Okay. Good enough?
Yes.
All right. All right, so number 11, again, just totally switches. There's one way of thinking is you give the questions in kind of an order of what you learn, builds on another is just random. I don't really know why you do one or the other, but I know that for us learning right now, we're just moving back and forth. So this one asks you to find f of 1, and then f of 5, and then f of 4.
Mhm.
So with a piecewise function like this, you ask yourself, is 1 less than or equal to 4? And it is. So since 1 is less than or equal to 4, you're going to use this over here on the left. You're going to use 1 squared plus 2 times 1, which is 3. Then you ask yourself, is 5 less than or equal to 4? No, 5 is not less than or equal to 4. Then you say, okay, well, hopefully 5 is greater than 4. It is, because we're doing 5 now. So it's 3 times 5, which is 15. And then 4, is 4 less than or equal to 4? Yes. So it's 4 squared plus 2 times 4, which is 24. And then you just match up the one that that matches. Is that okay?
Yeah, that makes sense.
Great. So 12 is another conic section question.
Mhm.
Find the vertices. Okay. So the vertices are like the endpoints. It's like if it's the football that's going up, it's it's either these, or if it's the ones that are sideways, it's these here. Okay. And it's based on, what is it based on? It's based on this this formula sheet that I guess I'll send you in the chat. I find it really useful. I would recommend printing it out and using it as you study. But we're looking at these ellipse stuff again. So the vertices depend on whether it's horizontal or vertical. So the way you know is you look at the numbers under X and Y.
Mhm.
So A and A is bigger than B. So whichever one is bigger is A. So this is 10 squared, so that's A, 6 squared B. And so on here. So that allows us to find C, because C is what we really need to find the vertices. Actually, we don't. We actually just need A for the vertices.
Mhm.
Take that back. So I guess this is a short problem, because if you know this formula and you know that it's horizontal and you know that you only need A, you look at the bigger number, 100, you take the 10, and you know that it's plus or minus 10. But there's a lot there to get to that.
Mhm.
And you can see I'm relying heavily on this equation sheet, which I don't know if you will have, but that's really the only way to do this, quickly, is to have that with you.
Mhm.
What's next? So 13 is, very different, but it's pretty straightforward. It's something you've probably even seen in a previous class. So here you're trying to evaluate log base 4 of 64. You can rewrite 64 as 4 to the power of 3.
Mhm.
Okay, and then there's this property that says bring that exponent out in front. So this becomes 3 times log base 4 of 4. Whenever your base equals the thing you're taking the log of, it equals 1. So this is 3 times 1, which is 3.
Mhm.
So that's not right, but that is. It is definitely C. All right, 14. So again, I'm going to snip in that that ellipse stuff that we've been doing, because I think it's really helpful here to have. And so this one has a vertical major axis, which means that because A is bigger than B, A is always bigger than B, and A is under Y this time, it's vertical. That's the vertical major axis. That the since A is greater than B, A is going to be, let me just check these. So this one is out because the bigger number is under X, and this one is out for the same reason.
Mhm.
So then you're just down to these two. You can use these values to find the major axis. So 2A is the major axis. So I was going to say, like this is, since this is 4 squared and this is 2 squared, you can maybe use that to say, okay, well, that's 4 and 4.
Mhm.
And then the other ones, see, why doesn't it touch? Sorry, I guess I need to look this up. We're jumping right into these, and you really would like to see a little more. Are you only doing ellipses?
I think we are.
Well, that's good, because that at least gives you some hope here of being able to do this. Oh, is that 2? Oh, okay. All right. I thought this line was 2. Okay. Okay, this does work. The 2 tells you that point because it's 2 squared, and the 4 gives you that point and that point. So if you know enough to do that, you would get it down to either B or D, but you would need to know the difference between the two. If this is bigger, the vertical is bigger, that's how you know it's a vertical major axis. Okay. And then we get one like 15, which is much easier to kind of understand and do. So I mean, if maybe spend more time on the ones that are are more common to you. So it's decreasing if it's going down and to the right.
Mhm.
So you can see it's decreasing, and I'll switch colors here. It's decreasing along here. So we need the x value. So the x value is like, wow, it's really weird how poorly that's graphed. -3, and then it goes to, I'll say 9.
I think so.
It's also supposed to be an open interval. I don't know if you get extra credit for like noticing mistakes, but you could point that out if you wanted. But it's increasing in the other intervals. So it's increasing over here on the left and it's increasing over here on the right. And that's kind of what's asked here on 16. 16. Okay, so this one's asking where it's increasing.
Mhm.
Increasing question mark. So that's where it's going up and to the right. So I'll label it in green,
Mhm.
different color this time. It's right there. So it's the x values though. So it's, I don't know, -5 to maybe 5. And again, it's actually only supposed to be an open interval.
Mhm.
Okay, 17 here, looking for 17, there it is. Mouse just got slow. Okay, find the domain of the following function. So there's really only 2 things in math that you can't do. And one of them is divide by 0.
Mhm.
You never want to divide by 0. So that's the first thing you're looking for. You're like, where is the bottom equal to 0? Where is 2x plus 2 equal to 0? 2x equals -2, x equals -1. So that's a bad point. So it's everything besides that. So if you're looking at a number line here from -infinity to infinity, at -1, it's that, but it's everything else is okay. So it's everything from -infinity to -1, -1 to infinity. These include it, but these don't include it over here on D. So that's why D is correct. Okay, moving on to 18 now.
Mhm.
Okay, if you want me to do anything different, please let me know. We can always try to find problems like this or whatnot, but this is kind of your review.
Mhm.
All right, so it says use synthetic division and the remainder theorem to evaluate P of 3. There's really 2 things you could do here. One is you could literally just put 3 in to these,
Mhm.
which is weird that that's not an X. But okay. The other is to actually do synthetic division. But if you're not graded for your work, why wouldn't you just put 3 into this? So I'm going to assume there's an X there.
Okay.
for the moment. So this is 27 plus 81 plus 9 plus 1. And that does work out. That ends up being 118. If you want, I can show you how to do this with synthetic division. You tell me if you want to go over that.
I think it's okay. Because if it's going to be multiple choice, I don't think she really grades on work.
No, they're trying to get those done as soon as possible because they want to go on vacation or get home to family too. So it goes both ways. You know, you want to get out of there, and so do they. All right, so there's this one is asking you to combine the logarithms. So there's a bunch of rules that you need to be able to use. You first deal with the numbers on the outside. So I mentioned this a few times, n log base b of x. This n actually can come up here. So it becomes log base b of x to the n. So for this one up here, it becomes log base 7 2 to the power of 3. And then over here on the left, it's log base 7 of 3 plus that.
Mhm.
Okay, so 2 to the 3 is 8. So we can say log base 7 of 3 plus log base 7 of 8. And then now your next property is log base b of a plus log base b of b is you end up multiplying them. So this plus becomes a multiplication. So it's log base 7 of 3 times 8.
Yeah.
So it becomes a log base 7 of 24. So that's last one here. All right, so the last one here is to sketch a graph of the function. So one of the differences between this one and the first one is that when it's a power of 2 or 4, basically whenever it's an even power, it touches, meaning it does not cross. Like it either, if this is the axis, it either like comes down and touches like that or touches like that. Whereas if it's an odd power, which is what is going over here, x minus 2, it crosses.
Mhm.
So we're looking for something at 1 that touches. Now these graphs are so terrible that I don't know how you can see this, but at 1 and 2, but that's what we're looking for. So hopefully yours is better on this. The other thing we can do is that if you were to expand this, it would be x cubed positive, which means it starts low and ends high. So that gets rid of that one and that one there. B is the correct answer. You can kind of see that there's a root there and there. It's not very clear. I mean, they could do a better job of sketching that for you. I don't know what they used to create this, but something from 20 or 30 years ago. Okay, 21 here. Solve, no, find the inverse. Find the inverse. 22 is solve the system. Find the inverse function of f of x equals 1 over x plus 2. So to find an inverse, there's a recipe, and there's some steps here. One of the steps is you replace f of x with y, so it becomes y equals 1 over x plus 2. Step 2 in our recipe here is you switch x and y. So x equals 1 over y plus 2. Third thing here is you solve for y. That's the most difficult step. That's the one that takes the most time. So see how y is on the bottom here when we have two fractions. You can cross multiply or butterfly here. So you get x times y plus 2 equals 1. 1 times 1 is 1. you can divide by x. You don't need to distribute. That's a mistake because you're trying to get y by itself.
Mhm.
And then you subtract 2 from both sides. So you get y equals 1 over x minus 2. And then there's a last step to replace y with f inverse, but I think you got it here.
Yeah.
All right, so there's this one's to solve the system. You do not want to try the answers. If you try the answers, you have to try them in both. And I'm not sure that that's a fast way to do it. It would work. If you had a calculator, you could actually put this into your calculator and just ask it to solve it. I
Mhm.
don't know if you've covered that yet, but the more common way here is for you to use elimination.
Yeah.
Now, what's interesting is that both x and y are opposite in sign.
Mhm.
Normally you choose the one that's opposite in sign. So I'm just going to arbitrarily multiply the second one by 2. So minus 8x plus 20y equals 8. And then I recommend rewriting the equation, not trying to or at least like covering that one up, but I would probably rewrite it.
Yeah.
And then you always want to add. You rarely want to subtract this. So you get 0, 0 equals 16. Does 0 equal 16? Is that true or is that false?
False.
So when it's false, that means there's no solution.
Mhm.
Not to be confused with infinite solutions, which is something completely different.
Yeah.
And so on here. Okay. Great. Another ellipse thing. It's so weird. Really weird. All right. The equation is not in a form that we're used to seeing. We're used to seeing 1 on the right hand side, but it's not. It's 64. So we divide everything by 64. And rather than trying to figure out what the fraction is, like it's better to just say, what is 64 divided by 16? Oh, it's 4. So I put a 4 on the bottom. 64 divided by 4 is 16. So that's y squared over 16 equals 1. And I'm going to snip in this reference sheet yet again, because without this, you just really struggle. So again, your A is greater than B, and it's because of this down here. A has to be the biggest one, otherwise this thing would never hold.
Mhm.
Okay, so A must be 16 because 16 is bigger than 4. So A is really 4 squared, and that's 2 squared, and that means it's a vertical major axis.
Mhm.
So that means it's either this one, D, or it's A. A looks a lot like a circle. So we could probably just go D
Yeah.
with that. If you just looked at the numbers 4 and 16, you would get it down to B or D anyway. So you still need to know the difference between vertical and major, or I'm sorry, vertical and horizontal.
Mhm.
So 24 is it's a nice problem, because it's kind of a, whenever you're given the graph and just asked to like identify stuff about the graph, that's great. It's like the dream here. So there's the vertex, boom, and then the intercepts are right there and there. So it's just matching the information here. They don't give you so many multiple choices that you can't usually get it down to like 2 after each one. So it looks like the vertex might be at like 3 minus 9. And actually A is the only one with that. So there you go. Unless they've changed this, I mean, a lot of the questions are like that on this midterm.
Yeah, I think they probably will be.
Okay, so this one wants the correct graph of the absolute value of 2x plus 5. It's a lot like quadratics in that there's like a vertex here. I don't know how clear that is, but it's like f of x equals absolute value 2x plus 5 halves. And then this is like your x minus h plus k over here. So this is your your k in your problem here is 0, and your h is minus 5 halves, and that just tells you where the vertex is, this point here. So your vertex is at minus 5 halves comma 0, and the only one that matches is this one right here. So it's definitely B. Now another way to do it is just set it equal to 0, and the only way it's 0 is if what's inside the absolute value of 2x plus 5 equals 0. When you solve for x, you get x equals minus 5 halves. 26. All right, so there are no known ways to factor a cubic. You have to know a 0 to like proceed. And since we're given some zeros over here, we probably want to just try one and see if they work. So we want to use like synthetic division.
Mhm.
So I'm going to try the -1 first, and I'm going to use the coefficients here. So it's 1, 6, 7, and -4. So it's 1 multiply -1, 5, -5, 2, -2. So that did not work. So that one's out. That's one of the good reasons to do that. Probably should have tried -4 since it's in both of those. Wasn't paying enough attention to that. Let's do that over here. So let's say it's -4. Then it's 1, 6, 7, -4. So bring the 1 down. -4, 2, -8, -1, 4, and 0. So there it is. So it's one of these. Okay. Then this thing reduces to x squared plus 2x minus 1. And based on these answers here, you're using quadratic formula. Okay.
Mhm.
So a equals 1, b equals 2, c equals -1. So your quadratic formula is minus b plus or minus the square root of b squared minus 4 times a times c all over 2 times a. So if that's not clear, I mean, we can look that up and do it again, but you've probably been doing this for a while
Yeah.
here. So that's 4 plus 4, that's 8 over 2. So this becomes x equals -2 plus or minus 2 square root 2. That's what 8 reduces to, all over 2. So you divide both of these by 2. So you get x equals -1 plus or minus the square root of 2. And that ends up being answer C. All right. Let's look at number 27. All right, so it says to solve this logarithmic equation for x, whenever there's no base here, you assume that it's base 10. That means that it's base 10. So it's really log base 10 of x equals -4. To undo log base 10, it's 10 to the log base 10 of x equals 10 to the -4. You might think, well, how does that help me? Well, that gets rid of the stuff on the left. So it's x equals 10 to the -4. And 10 to the -4, there's really a 1 out in front. So it's like 1, and then you move the decimal. So you move it left here. 1, 2, 3, 4. You put the zeros there. So that's how you get your final answer. All right. Let's do 30. That's probably the last one we can do, given the
Okay.
amount of time without a lot of explanation. Plus, it's kind of like one we already did. So again, your methods are substitution and elimination. You'll probably use elimination most of the time here. What you're looking for is like either multiples, like see how 2 and 4 are kind of multiples of each other. So if you multiply the first equation by -2, okay, you get 4x down here from -2x because you're multiplying everything,
Mhm.
plus 6y equals 28. You got to multiply everything. And then that's gone. So you're just looking at these, these right here, and you add them up. So that's 0, that's 2y, that's 4. So you get y is 2 when we looked out.
Oh, yeah.
If you didn't know, you would put the 2 back into one of the equations. So it'd be -2x minus 3 times 2 equals -14. -2x minus 6 equals -14. Add 6 to both sides. So you get -8, and then x equals 4. That does take us to the end of our lesson. A lot here. There's definitely a lot here. I would focus on like the stuff you know really well, and then decide how much time you want to spend on like ellipses, because there's going to be some number of questions on there
Mhm.
about it. But thank you so much for scheduling. I really appreciate it. If you need some help before your final exam, I'll definitely be available, and I'll see you next time.
All right. Thank you.
Have a great night. Bye now.